Good morning and welcome to the third annual Right-of-Way Asset Mapping Exchange, part of ConnectMii event's ongoing series on asset mapping. My name is Matteo Luccio and I will be your moderator for this event. By the way, I'm a writer and an editor, not a public speaker, so please forgive me if I look down at my notes. If you thought you were on the flight to Honolulu, now would be a good time to get off. Otherwise, please fasten your seatbelts and prepare for 2.5 hours of presentations, discussion, and questions and answers on innovation in asset inventory and mapping that supports all phases of infrastructure life cycles. In particular, this year we are focusing on subsurface utility engineering. I'm the editor-in-chief of the magazine GPS World, which has been published every month for 32 years. Therefore, your first thought may be, today we are focusing on subsurface utility engineering, and GPS does not work underground, so why is this guy the moderator? Well, I have been covering all the geospatial technologies, satellite navigation, geographic information systems, land surveying, remote sensing, etc., for more than 20 years for a variety of trade magazines. Also, GPS and the other global navigation satellite systems, or GNSS, the Russian GLONASS, the European Galileo, and the Chinese Beidou, are essential to mapping features above ground to which the ones below the ground are referenced. Additionally, I have a personal interest in today's topic because my paternal grandfather was the chief engineer for the construction of the subway in Milan, Italy, for about 20 years, and his brother was the chief engineer for the construction of the subway in Rome for about the same period. So they had to deal with relocating many subsurface utilities, many of them hundreds of years old. They did not have ground penetrating radar, vacuum excavation, or subsurface mapping. I wonder what they would think of today's technologies to locate and map underground features. Now let's see who you are. So here's the first of 4 poll questions for you to answer during today's event. And this one is about your employer. So you should see it up on your screen, and I'll look at the results in a few minutes. In 2020, this event focused on the challenges faced by cities in managing their infrastructure while becoming smart cities. Including such topics as installing broadband connections, aerial-based data acquisition, and mapping and managing change in asset mapping and acquisitions. We also began a discussion in 2020 on mapping the underground. In 2021, topics included the role of augmented reality in data collection, leveraging artificial intelligence to capture nationwide ROW map data, and the use of mobile LiDAR to capture pole audit data. This year, we will focus on a new standard promulgated by the American Society of Civil Engineers, ASCE 75, guideline for recording and exchanging utility infrastructure data. I will get to that in a moment, but first let's talk about right-of-way mapping more broadly, and in particular about subsurface mapping. That's SUM, referred to as SUM sometimes, and for subsurface utility engineering, or SU. So SUM for SU. Now, right-of-way corridors, especially in urban areas, are densely populated by many public and private infrastructure features, including overhead electric and telephone wires, street level parking meters, signage, traffic sensors, and so forth, and underground fiber optic cables, water mains, natural gas pipes, and sewers. They are constantly changing environments as additional poles, signs, and conduits are installed, and old ones are replaced with newer ones to restore service after storm damage. Yet public works and utility managers, engineers, and planners need to know what each stretch of each ROW corridor contains at any given moment, especially as they work to make our cities smarter. Hence, the Sisyphean task of mapping these assets over and over again. Fortunately, the technology to map ROW assets is continuing to improve rapidly. Platforms for data collection include vehicles driving at normal traffic speeds, UAVs, and manned aircraft. Sensors include digital cameras, LiDAR scanners, and, as I mentioned earlier, ground penetrating radar, or GPR. Visualization tools include augmented reality, virtual reality, mixed reality, and models ranging from small 2D and 3D ones of individual features all the way up to digital twins of buildings and eventually entire cities. Increasingly, the tedious work of identifying and classifying features is being delegated to automated feature extraction software, a form of artificial intelligence. Now, accurately knowing the intricacies of your project's subsurface environment is often a critical factor in a project's success. When combined with underground utility records, subsurface utility mapping delivers the insights on which your team can rely. It minimizes risk, improves project execution, and minimizes changes and claims. Precise sum 3D data improves on legacy utility plans and GIS data to provide valuable information in the preliminary stages of project planning, helping design professionals minimize design conflicts, avoid cost delays due to surprise discoveries, and mitigate the risk of striking undocumented utilities in the construction phase of a project. In the past, some surveying methodologies ignored and oversimplified historical data on existing underground elements. Poor record-keeping principles have often exacerbated the challenges that project teams face when working in brownfield environments. Additionally, utility companies and contractors often abandon or move underground utilities without properly recording these changes. Therefore, available utility maps may be dated, incomplete, inaccurate, and generally untrustworthy. This has led to costly mistakes on major projects, with effects ranging from small financial burdens to litigation, settlements, and frankly, tarnished reputations. For these reasons, projects cannot afford to overlook the opportunity to complete a subsurface utility investigation in the preliminary stages of a project. After all, major projects, every major project begins with comprehensive environmental and geotechnical investigations, so why not a subsurface utility investigation as well? SUM creates color-coded 2D and 3D digital delivery formats of underground utilities to depict and map the underground location of the critical infrastructure that can be delivered in computer-aided design, CAD, building information modeling, BIM, or GIS formats, helping project managers and engineers better understand the complexity of their project's below-ground environment and facilities. I hope that today's presentations can help us understand the relationship between this technology and the standards. So back to ASCE Standard 75. It will be the successor to the ASCE 38 standard, guidelines for the collection and depiction of existing subsurface utility data, which is now 20 years old. ASCE 75 will likely become the subsurface asset mapping standard. The purpose of this standard guideline is to specify essential elements for recording and exchanging data about the location, size, orientation, function, ownership, and other attributes of underground and above ground utility infrastructure, with a focus on newly installed, repaired, or otherwise exposed or accessible utility infrastructure. This standard guideline establishes minimum, optional, and conditional elements of spatial and non-spatial attribute data associated with utility infrastructure. The standard guideline also provides recommendations for effective practices to facilitate data exchange among project stakeholders. The guideline is critical to capture, document, and exchange utility data for project scoping, planning, design, construction, operation, and long-term management of utility systems, as well as the management of public right-of-way and properties throughout which utility infrastructure are installed. It is also essential to facilitate interaction among stakeholders for managing utility and other civil infrastructure. Now, a leading force in developing that standard, ASCE 75, was Phil Mice, Principal Engineer and Business Development Lead at Utility Mapping Services in Montana. Unfortunately, Phil was not able to participate in today's event, but I am sure that our first speaker, Tom Pilarski, will do a great job of explaining what's in this new standard, how it differs, not yet, Tom, from its predecessor, and why that matters. As the old joke goes, what's great about standards is that there are so many of them from which to choose. In this case, however, ASCE 75 is the one that matters. As you might know, adoption of ASCE 38 was a bit uneven throughout the country. For example, several state departments of transportation adopted the standard wholeheartedly, while some, such as Caltrans, did not. Perhaps Tom and our other speakers today have some thoughts on how adoption of ASCE 75 is proceeding. So one housekeeping note, as you've already seen, the Q&A, for questions, please press the Q&A button. Speaking of which, I'm reminded about the poll. And let's see, can we see the results of the poll? So let's see here, state government, 23%, local government, 22%. So that's a whopping 45%. So almost half of our audience is from state and local governments. And then we have 6% from utility companies, 14% contractors, and 34% consultants. That's a sizable number. So as far as those of you who work for state and local government, you'll probably particularly appreciate the presentation by Rob Martindale in a little while from the Colorado Department of Transportation. Without further ado, let's turn to our first presenter, Tom Pilarski. And Tom, please introduce yourself and take it away.